I'm delighted to welcome our next speaker to the stage. This is Anna. This is the first time that Anna's spoken at a Python conference. I've told her that you're a fantastic audience, so be fantastic. Anna.
So, hello everyone, my name is Anna. You might not believe it because of the weird setup, but I do work in tech. I am a developer at a company called MoneyFarm, and I've been programming in Python for 6 years now. And I'm here to share with you a little bit of my experience. My talk is nowhere near as cool as the previous one, so bear with me, but it's supposed to be an overview more for beginners and also for people who work in Python but are wondering where Python is used today and how they can expand their field of expertise or just have some fun with it. If you do want to dig deeper in any of the subjects I will be touching, I'm around today and tomorrow, so feel free to come and ask any questions. There's my contact there as well, so if you drop me a line or something, you're welcome to. So I'm going to start with where's Python being used today. So companies like Instagram and Pinterest are built with Python. Twitter was Python until a very short while ago. And all of the other companies use Python for most important bits and pieces in their stack. So also one of the most trend usage of Python is artificial intelligence. So social media companies use Python to recommend you best content based on your likes and your activity. Finance companies like MoneyFarm, which is the company I do work for now, they use Python to track market evolutions and help our asset allocation team to make better informed decisions. E-commerce companies use Python to recommend best products based on your previous purchases. Science companies use it for simulations and modeling. And film companies actually use to render cool special effects and images. So why Python then? Python is a very simple language to both read and write. So if you have seen Python before, it actually looks pretty much like simple English. And the best thing of it for both individuals and companies is that you can quickly turn ideas into practice very quickly, and you can integrate with many other applications in many other fields. And it's also a great language for beginners because of this. You won't get like weird concepts that you need to understand first before starting actually to build stuff. So this is what Python looks like. I'm going to show you a bit of code. If you don't understand, maybe you can ask a bit later, but basically you can use integer numbers and floats as well. You can save the results in variables. You can have more complex structures and ask information about that. You can draw instructions in, like I said, for simple English. So this should be quite easy to get what it's doing at least. But sometimes you want to do some more complex stuff. So when you do want to repeat patterns, you can define more complex structure. For instance, here we say that a dog is something with a name and a list of tricks. So every time you want to create a new dog, you just need to say his name and what tricks he does. So this is actually quite powerful. And also one of the biggest advantages of Python is package index, which is huge. As of yesterday, there are 88,567 different packages. And what a package is, it's just a piece of functionality that comes with everything you need in it. For instance, in the dog definition before, it might have, like, there might be a package that has some dog in it, and you wouldn't need to code it again. You would just call the dog thing, and you could, out of the box, define its tricks and its name. So Python is kind of the modeling clay of the material world. You can grab it, can assemble it to different colors and pieces, and you can build your masterpiece. So one of the most users of Python today is actually for scientific purposes. So the Syfy stack is widely used as a replacement for proprietary software such as MATLAB, for instance. In the example on your left, you see a simple plot that can be done with 4 lines of code. And that is because you are importing packages. So the packages actually hide all the complexity, and you only need to actually call the simplest stuff to get your graph going. And one of the amazing stuff that you can actually solve Schrodinger's equation for a simple potential like this without actually getting to know physics, because you only need to get the equation going, you plot it, and Python does all the hard work for you. And this example uses actually machine learning. So you see, again, it's a very simple code. And what this does is it fits some data that was previously collected. For instance, here we're analyzing the iris petals, so we're comparing the sepal width and length. So what this does is it gets the previous observations of width and length, and it fits that data into a classifier. And then when you have new data and want to check what kind of flower it is, it's not very clear in image, but there are 3 kinds. And when you want to predict with a new observation, it actually returns the predictable result. So this is a common example in machine learning, but you can see that you can apply it to any case study that classifies as this. So at this point, we're wondering, like, there are really many things you can do, from the movies you watch in cinema to news you read every day to when you go to the doctor, for instance. So it's like Python is like a Swiss Army knife that does everything for you. And there's this great book called Automate the Boring Stuff, which actually it's great for if you're starting out, and also if you want to do some practical examples and actually automate some of your everyday tasks. For instance, if you work with files a lot in your routine, you can actually write a Python script that handles all the hard work for you. So, for instance, if you want to track your schedule, you can see here the code to create a stopwatch. So what this does is only every time, if you run the script, and every time you hit enter, you actually get like a new lap. So if you want to track different tasks, Python records the time you spend on each task. And you can actually integrate this with other stuff. So if you want to add a description of your task, you can write that description into a file, and when you click enter, you can have Python write into that file the description and how much time it took. So at the end of the day, you have your schedule without doing a lot of effort. But also, if you are into computer science, Python is great to learn all of the computer science stuff. So if you like to build games, you can learn a lot of computer science by building games, because you have to learn a lot of data structures and improvements on complex algorithms. So you can also like use encryption algorithms. And by the previous talk, we know we need to be careful with pseudo-random generators here. And also, if you want to build a Facebook competitor, you can build your own social network. And you'll see that it takes a lot more than just a few likes to actually build and the friends network. What if we want to share all of this with other people? So Python is good for that as well. So Python has a lot of web interfaces and graphical user interfaces you can use to give a face to your applications. So the most well-known actually, I think, is Django, is widely used across industry, and that lets you build an end-to-end web application where you can build your Python app in the back end and show the results in the front end with HTML code. But, yeah. And here we see also a very nice use of web services, which is web scraping, which you also need to be careful with because this is still a gray area in legal terms, because it's not, some websites, they forbid it. You should read before you try scraping anything. But what this does is just, it gets the whole page of the URL you want, anything. And then you use a parser to get the information on that page. So for instance, here I'm just getting the title of the Google page, but you can actually do a search and get the first result, all with Python, without needing to go actually to the web page and compute all of that. So one of the other things I couldn't miss in this talk is the open source projects, because Python and the package index is a lot of open source projects. There are a lot of open source you can contribute. Here we see also NASA as open source project, which if you build some cool application for them, you can submit and put your project in their source code, which is amazing. And open source is very nice for programming and for collaborating and for building better software. And even if you're starting out, it's good to learn and see how other developers solve some problems and to see how things work actually under the hood. So I hope you've got some good takeaways of this, even if you don't know any Python or any programming, or even if you do, I hope I could teach you something today. And to finish, I wanted to leave one of beautiful Python poems, and which belongs to the Python enhancement, and it's basically the philosophy of Python. Take a moment to read it, and then I'm available for any of your questions.
Thank you. Happy to take questions back. Can I ask the first question?
Yeah.
Which is your favorite of these
Lines.
lines? Yeah.
It's hard to pick favorites. To be honest, I think it actually kind of changes with the experience, because when you start out, you see that readability really counts, and once you pass that, you see like errors never pass silently, and special cases aren't special enough to break the rules, I think.
So you said you've been a developer for a few years now. Of the technologies you presented, which ones do you use in your day-to-day work and how?
So right now, actually, I'm not using Python in my work, but this is very recent. Yeah, but this is very recent. But okay, so when I worked with Python, I was building Django applications. So Django is one. I used the scikit-learn library for some. Okay, so I worked in a web agency, so we built a lot of different applications for different industries. So I've built applications for finance industries where the Syfy package was amazing to compute values and to track the market values and to build the graphics and statistics for the client. I've worked with medical software, and that only uses like more advanced Django stuff and Python. But in terms of different packages, I think Syfy was most important in my work life.
One of the lovely things about having the speech-to-text people here is some of their, I'm not sure what the word is, but Syfy is spelled S-C-I-Y, but I'm going to call it Syfy, as in hi, from now on. Okay, do you have questions about?
Yeah, two questions.
Okay.
Yes, actually I've got a slide with resources after this one. Maybe I can share this presentation somewhere, or...
There will be space on the website for speakers and workshop leaders to put their notes and things.
Okay.
So check that, or if you tweet it, we'll retweet that as well. Are you all following the conference Twitter handle? You should. It's at Pycon UK. Good. There was another question from. Hello.
When did you first discover Python? What brought you to it?
So I first discovered Python in university. So I have a physics degree. So in physics we do a lot of simulations and calculations. So, and then I realized that I like that more than actual physics. So.
Any more questions? What one piece of advice would you give to somebody who's starting to learn to code Python for the first time?
Don't be scared. And don't get like too fed up with books. Just open a terminal or something and print stuff, break stuff, try it, see what works, what doesn't work, and everything will come together nicely.
And then ship it anyway.
Yeah.
Okay. Well, thank you, Anna.
Thank you, guys.